All right, scholars, today we're going to start on lesson 9. The objective for lesson 9 is to decompose a liter, to reason about the size of 1 liter, 100 milliliters, 10 milliliters, and 1 milliliter, okay? Vocabulary that I want you guys to be thinking about is liquid volume. Liquid volume is the space a liquid takes up, okay? A milliliter is a unit of measure for liquid volume. Here it says it's about 20 drops. Usually 1 milliliter is about 1 drop, okay, depending on the dropper. All right. A liter is a unit of measure for liquid volume, okay? Example, 1 jug of milk, and we're not talking about the big gallon size milks. We're talking about like the little ones, is about 1 liter, okay? Measure, a quantity representing a weight. A quantity representing a weight or liquid volume, or the act of finding the size or amount of something. So that's what measuring means. Means you're getting like a tape measure and you're going to measure something, or we get our scale to measure the mass of something, or when we use a measuring cup to measure the amount something holds, right? A liquid volume, a liquid measure, okay? So these are some words that we're going to be talking about today, okay? All right. So for concept development, we're going to watch this video on decomposing liters into milliliters, okay? And we're going to pause periodically to to answer some questions, okay? Does anybody have any questions?
Oh, hey guys, I'm just trying to fill this jar with 1,000 of these little drops. 535, 536, 537. Wait, this is crazy. There's got to be a better way. How about we see if I can decompose 1 liter? A liter is a unit used to measure an amount of liquid.
All right, so she's giving you the definition of a liter, okay? A liter is a unit to measure the amount of liquid, okay? So when we are measuring liquid, we are going to be measuring in liters, okay?
This is a 1 liter beaker. Its capacity is 1 liter. Capacity means the total amount it can hold. Right now, it's filled about halfway. So is this beaker filled to capacity?
All right, so she told us what capacity means. Capacity is the total amount something can hold. So like the capacity of my beaker here is about 600 milliliters, okay? And if I filled it up to 300, do you think it would be filled to capacity? Is that the total amount that this beaker could hold? No. So when we're looking at this, it says, is this beaker filled to capacity? Do you think this beaker is filled to capacity? Thumbs up for yes, thumbs down for no. All right, I love seeing all these thumbs down. So no, this beaker is not filled to capacity.
No. The capacity of this beaker is how much it can hold in total. Its capacity is 1 liter, which we can abbreviate as a capital L. Now let's decompose our liter into 10 equal units of a smaller measurement called milliliters. We abbreviate milliliters as a lowercase m, capital L.
All right, so that's something very important to take note of, okay? When we measure in liters, guys, when we're measuring in liters, that L is capitalized. When you're measuring in milliliters, the L stays capitalized. So it's a lowercase m, capital L. So that's why when you see Miss Lambert typing ML, I always have that capital L. So milliliters is lowercase m, capital L.
So here's our 1 liter poured into 10 equal cups with none left over.
Okay, so on page 187 of your book, okay, page 187 of your book, part 2, letter C says, illustrate and describe the process of decomposing 1 liter of water into 10 smaller units. So when you look at this picture here, that is the process of decomposing 1 liter into 10 smaller units. So I want everyone to take some time to draw what you see here on part 2, letter C. All right. This part right here says it's 1 liter, right? It says 1 L. And this is decomposed into 10 smaller units. We know because we can count. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? All right, so let's move on.
Each of these cups has a liquid volume of 100 milliliters. Let's skip count by 100 to find our total. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So how many 100 milliliters are in 1 liter?
All right, so her question is how many 100 milliliters are in 1 liter? We just counted them. So how many 100 milliliters do we have in 1 liter? Mr. Carrington?
1,100 milliliters.
You think there's 1,000 of these? Look, hang on. We're looking at these right here.
10.
How many of these are inside 1 liter, right? These are 100 milliliters, right? How many of these go into the 1 liter beaker?
10.
10, there we go. So we have 10 100 milliliters in 1 liter, okay? There we go. All right, so let's watch.
We have 1,000 milliliters in 1 liter. That means that 1 liter is 1,000 milliliters.
All right, let's pause there. 1 liter is 1,000 milliliters, okay? 1 liter is 1,000 milliliters. Do you guys remember in kilos? 1 kilogram, right? 1 kg is equal to what? 1,000 grams, right? 1 kilogram is equal to 1,000 grams. And 1 liter is equal to 1,000 milliliters. Doesn't that seem curious? I think so. Let's keep watching.
So wait, when I was using the eyedropper, I was pouring 1 milliliter at a time. How many pours of 1 milliliter would it have taken to fill the 1 liter jar to capacity?
So if 1 drop is equal to 1 milliliter, how many drops do we need to fill a 1 liter container, guys? Gerardo. To fill up a whole 1 liter? How many milliliters make up 1,000? So we need 1,000 milliliters or 1,000 drops to fill up a whole liter. Man, she's gonna spend a whole lot of time dripping and dropping, huh? To make 1,000? That's going to be a long, long time.
We know that 1 liter is equal to 1,000 milliliters, which means it would have taken 1,000 drops. Oh man, that would have taken forever. But wait, these drops can be used for something good. What if we wanted to decompose this cup of 100 milliliters? Let's split this into 10 equal parts. How much liquid will be in each of the 10 parts?
All right, so if we decomposed 100 milliliters, right? So this guy right here is equal to 100 milliliters, okay? If we were to break this apart into 10 pieces, okay, how many milliliters will be in each cup? So what we're doing now is we're taking 100 and we're dividing it by 10, right? And that'll give us how many milliliters. So let's skip count by 10 until we get to 100, okay? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So how many milliliters will be in each cup, guys? 10. So right here, our 10 milliliters are going to be in each cup, right? Let's see what she says.
If we decompose 100 milliliters into 10 parts, each will have 10 milliliters. That's 100 divided by 10. That's great, and way faster than using this eyedropper.
Okay. All right, so here we have the same slide that we had when we were looking at kilograms last week, right? So we have 1 liter right here. This is our 1 liter. I can also write 1,000 milliliters right here, right? Because it's 1,000 milliliters. All right, we can break this liter down into 100 milliliter parts, all right? Each one of these little packets right here contain 100 milliliters, and there's 10 100 milliliters in 1 liter, all right? You can break down 100 milliliters into 10 milliliters, okay? Okay, yes, Peyton, you can go. All right, so this is the same thing we did with kilograms, so they're very, very similar, right? Very similar. All right. Okay, so we're going to do part 1 of our problem set together as a class, okay? We're going to do part 1 together as a class. So everyone needs to open their books to page 187. Everyone needs to open their books to page 187. Make sure you have a pencil. All right, so for our first container, I have my small Rubbermaid container here, okay? I have my Rubbermaid container. All right, it's full of water. Do you think this is less than, more than, or about the same as 1 liter? Okay. So when we look at like those big things of soda, those things are about 2 liters, but this is a food container, right? And on the bottoms of your food containers, it usually tells you how many milliliters it holds. So how much do you think this is, more, less, or about the same as? Anyone want to take a guess? Christopher took a guess. He said it's about the same as. Anyone else want to take a guess? Do you think it's the same, more, less? Preston?
More.
All right, he's saying it's more. Anybody else have a different guess before I give you the actual amount of milliliters this thing holds? All right, so Jorley says she thinks it's either the more or the same. So when I look at the bottom, of my container, it says that it holds 473 milliliters, okay? It says that it holds 473 milliliters. So I'm going to circle here, right? Less than, because 473 milliliters is less than 1 liter, right? Sorry, give me 1 second. I meant to circle this in a different color. So I'm going to circle less than, right? My food container. The actual measurement is 473 milliliters. Okay. My next container is my drinking cup. It's my silver Yeti drinking cup, and it's an extra big one that I drink out of all day long. Okay. So I'm going to write right here, Yeti cup. Everybody knows what a Yeti cup is, right? Do you think this Yeti cup is less than, more than, or about the same as 1 liter? Peyton, you want to take a guess? Do you think my cup is more, less, or the same?
More.
You think it's more? Camilla, you have a guess? Do you think it's more, less, or the same? All right. Anybody else have a guess? Christopher says he thinks it's way more. So the thing about these cups, guys, is when you open it, it's got big walls. Like it's insulated. It's heavily insulated. So the inside is smaller than it looks like on the outside. So this cup is about 1 liter, okay? It's a little bit more, but it's about 1 liter. So we're gonna put here about the same as 1 liter, okay? The actual is about 1,100 milliliters, okay? Which is about the same as 1 liter, okay? It's a little bit more, but it's still about the same as. It's about the same as you're gonna get when you're looking at stuff, when you're getting containers, okay? Container 3 is gonna be my lotion bottle here, okay? My lotion bottle, do you think this is gonna be more, less than, or about the same as? Do you think this lotion bottle is less than, more than, or about the same as? Peyton says more, Jamarian says more. Does anybody else have any different guesses? All right, so you can guess, you can put your guess in there. You can circle that. I'm gonna guess less, so I'm gonna put less than. And then we're gonna check the official measurement on the outside of the bottle. So this is my Nivea lotion, and we're gonna look right here. Our measurement, or the measurement inside, says it's about what? 400 milliliters, okay? The actual measurement is 400 milliliters. Okay. Okay. Our last container.
Lambert, I can't see anything.
For our last container, we've got this gallon of water. For our last container, we have this gallon of water. Kroger water, okay? Do you think this is more than, less than, or about the same as 1 liter? Okay. 1 gallon of water, do you think it's more than, less than, or about the same as? Let's see what kind of guesses we get. Christopher says way more. Anybody disagree or agree with him? Camilla says it's way more. Peyton says much more. All right, so we're going to circle more than, because you guys, that's what your guess is, right? The actual measurement, which is right here, if you look on your containers, this may not be able to be read real well. It says 3.78 liters. Okay, so it's 3.78 liters. If I turn that into milliliters, okay, hang on, I'm going to put 3.78 liters right here. This turned into milliliters is 3,780 milliliters. If you look on your gallon of milk, it'll have the same measurements in there too. 3,780 milliliters, or 3.78 liters. All right, part B asks the question of you, and it says, after measuring, what surprised you when looking at these different containers? What surprised you? What did you find surprising? And that's all your opinion. I just want to hear what surprised you the most. Okay. Okay. I'm going to clear this and we're going to move on. Okay. So for our problem set, part 1, we completed as a class group. Part 2, letter C, would be something that you would get from the video. And now during our problem set time, we're going to do parts F and G. Okay. Parts F and G only. And I meant to change this to say complete C. So we completed part C during the video, okay? And now during our problem set, we're going to do letters F and G. Okay? You have 10 minutes. Your time starts now. So now that our time is up, we're going to go ahead and move on to the next part, and it's our debrief. Our debrief says, what is this Sam about decomposing 1 liter into milliliters and decomposing 1 kilogram into grams? So what is the same about decomposing 1 milliliter into liters and decomposing 1 kilogram into grams? Okay, so the answer is, and I'm going to write the answer down, it works the same. 10 milliliters, 10 ml, lowercase m, capital L, 100 mLs, milliliters. I'm sorry, 10 mLs is 10 1 mLs, right? 10 single milliliters. 100 milliliters is 10 milliliters. So 10 cups of 10 milliliters is 100 milliliters, right? And 1 liter, 1L, 1 liter is 10 100 milliliters, right? So 1 liter is 10 of those 100 cups of milliliters, right? Both kilograms and grams and liters and milliliters grow the same way. Do you remember the pictures that I posted or that I showed you? The picture of the liter and the kilogram broken down into the hundreds and then broken down into the tens? They both do the same thing. You can look at them both, and they are the exact same picture, just with different letters. Okay. All right, letter G. All right, letter G says 1 liter of water weighs 1 kilogram. How much does 1 milliliter of water weigh? Explain how you know. Okay, so 1 liter of water weighs 1 kilogram. How much does 1 milliliter of water weigh? Hang on. So what they're asking us to find out, right, is what they're saying is 1 liter equals 1 kilogram, right? And so they're asking what is if 1 milliliter, what does it equal? So liters and milliliters, right, are the same, right? So with liters and milliliters, we have 1,000 milliliters equals 1 liter. 1,000 what equals 1 kilogram, guys? $1,000 of what equals 1 kilograms? Andrew, do you have an idea? I see it on your face. Yes, thank you, Peyton. So 1 gram is the same as 1 milliliter, right? So 1 milliliter of water will weigh 1 gram. Way to go. Give yourself a pat on the back, because that was a big, tough extension for our brains to make. All right, so the answer here is going to be, since decomposing 1 liter into milliliters is the same as decomposing 1 kilogram into grams, we know that 1 milliliter weighs, oh, can't spell, weighs 1 gram. Okay. Since decomposing 1 liter into milliliters is the same as decomposing 1 kilogram into grams, we know that 1 milliliter weighs 1 gram. Okay. The reason I want you guys to know this is because our books are like our notes, okay? This is how we know what we've learned so far and how we can keep track of the things that we have learned, okay? So it's important for us to know these things, okay? important for us to know that liters and kilograms are the same thing, or they can be interchanged. Okay, a kilogram of water is going to be the same, or a kilogram of water is going to be about 1,000 milliliters. Okay, and 1 gram of water is going to be 1 milliliter. Okay, and that's all I've got for you guys today. Okay.